Good morning everyone. Now let's see MCQs on permutation group. Yes. So first MCQ. A permutation is one mapping, onto mapping, one and onto mapping, not one, not onto. So obviously permutation is here function f goes from s to s, that is one and onto. Yes. So option C is the correct one. Option C is the correct one. One and onto mapping. A permutation is one and onto mapping. Next MCQ. Let S is equal to S contains 3 elements and f from S to S such that f of A is equal to B, f of B is equal to C and f of C is equal to A. Then the total number of permutations are. So we know formula in Sn there are n factorial elements are contained. Yes. So in there are 3 elements in S. So how many permutation we can make? So 3 factorial. Yes. So answer is 3 factorial. Okay. Next. Which of the following is an identity permutation? Identity permutation means, suppose this is a permutation on 3 symbols. So 1 maps to 1, 2 maps to 2, 3 maps to 3. This permutation is called identity permutation. That element in domain and codomain map to same elements. Yes. So here A maps to B, B maps to C, C maps to A. This is not an identity permutation. A maps to A, B maps to B, C maps to C. Yes, this is an identity permutation. Yes. Next MCQ number 34. Okay. So if F is equal to this permutation, A maps to C, B maps to B and C maps to A, then what is F inverse? How can we calculate F inverse? Yes, write domain as codomain and codomain as domain. Yes, means write interchange these two rows, interchange first change first row to second and second row to first. Yes. So here C, here A maps to C, means here C maps to A. Okay, B maps to B and C maps to A, means A maps to C. So option A is the correct one. Yes, all B, C and this D options are wrong one. Yes. Next MCQ. If F is equal to this permutation and G, then what is product of F into G? Yes, we always use left to right convention. Yes, means right here A, B, C, B, C, A. Yes, A, B, C, A, C, B. Yes. So how can you calculate this? C. Write domain first, A, B, C, means write first row A maps to B, B maps to C, means A maps to C, B maps to C, C maps to B, means B maps to B, C maps to A and A maps to A, so C maps to A. So select this one. Where is this option? C, B, A. Yes. So option D is the correct one. Yes. Option D is the correct one. Next MCQ. The product of two permutations is. Product of two permutation is always non-commutative. See here. In previous example, F into G is what? F into G is this. F into G is. If you calculate G into F, so G into F is what? Right here G first, A, B, C, A, C, B. F is what? A, B, C, B, C, A. If you calculate this, you will get A maps to A maps to B, B maps to C, C maps to A, C maps to B, B maps to C. So compare these two equation 1 and equation 2. Equation 1 is not equal to equation 2. So product of two permutation is always non-commutative. Yes. Next MCQ. Which of the following is correct? S1 is abelian. Yes, this is true. S1 is abelian. S2 is abelian. Yes, this is also true. For n greater than or equal to 3, the group Sn is non-abelian. This is also true. All these three statements are true, means all are correct. So option D is the correct one. Next MCQ. Let S is equal to this set 1, 2, 3, 4 and theta is a given permutation. 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 1. Here theta is a cyclic permutation. Then in one row notation. Yes, one row notation. How can we write this theta? Theta is equal to 1, 2, 3, 4. Theta is equal to 1, 3, 2, 4. Theta is equal to 1, 2, 4, 3. Theta is equal to 1, 4, 2, 3. So I have told you how can we write in one row notation. Theta is equal to 1 maps to 2. Yes, 1 maps to 2, 2 maps to 3 and 3 maps to 4. So which one is the correct one? Option A is the correct option. Yes. Next MCQ. Consider the statements. Every permutation is a cycle. Every cycle is a permutation. Select the correct answer from the following. Yes. So tell me which one is the correct one. This is an example from our book. Yes, both these statements are true. Both these statements are false. A is true but B is false. A is false but B is true. So we have already studied what? Every cycle is a permutation, but every permutation is not a cycle. Yes. So option D is the correct one. A is false but B is true. A is false but B is true. Yes. Next MCQ. This cyclic permutation. Yes, 1 maps to 3, 3 maps to 4, 4 maps to 1, 2 maps to 2, 5 maps to 5. On 5 symbols can be written as. Yes, how can we write this cyclic permutation? See, write 1 first. 1 maps to 3. Yes, 3 maps to 4 and 4 again maps to 1. So complete the cycle. Next 2 maps to 2 and 5 maps to 5. So write this or do not write. No, there is no difference, write or do not write. Yes, so 1, 3, 4. Answer is option 3. Okay. Next one. A cycle of length 2 is called, we know cycle of length 2 is called transposition. Yes. Next MCQ. Which of the following is not true for cyclic permutation? Yes, cyclic permutation. They are asking cyclic permutation. 1, 2, 3, 4. So we can write 2 maps to 3, 3 maps to 4, 4 maps to 1. So here also 2 maps to 3, 3 maps to 4, 4 maps to 1 and 1 again maps to 2. Yes, this is correct one. But they are asking which is not true. So this is true. 2 maps to, in second option 2 maps to 3, 3 maps to 4, 4 maps to 1. Here 3 maps to 4. Here also 3 maps to 4. Here 4 maps to 1. Here also 4 maps to 1. 1 maps to 2. Yes, 1 maps to 2 and 2 maps to 3. This is also correct one. C is also correct one. So check the D. 1 maps to 2. Here 2 maps to 3. See this 2 maps to 3 and here 2 maps to 4. So this is a wrong one. They are asking which of the following is not true for cyclic permutation. So option D is not a cyclic permutation. Okay. Next MCQ. The product of cycles 1, 3 and 1, 3, 4 on 4 symbols is. Yes. Tell me the product of cycles 1, 3 and 1, 3, 4 on 4 symbols. Product. Here on 4 symbols 1, 2, 3, 4 and again 1, 2, 3, 4. Here 1 maps to 3, 3 maps to 1, 2 maps to 2, 4 maps to 4. Yes. 1 maps to 3. See this cycle. 1 maps to 3, 3 maps to 4 and 4 maps to 1, 2 maps to 2. So take the product. How can we write this? 1 maps to 3, 3 maps to 4. So 1 maps to 4, 2 maps to 2, 2 maps to 2. So here 2 maps to 2, 3 maps to 1, 1 maps to 3. So 3 maps to 3, 4 maps to 4, 4 maps to 1. So 4 maps to 1 here. So you can write this as in cyclic permutation. Yes, product of cycle 1 maps to 4 and 4 maps to 1, 2 maps to 2 and 3 maps to 3. So you can write like this 1, 4. So option C is the correct one. Yes. Next MCQ, which of the following pairs disjoint cycle on 4 symbols? Okay, so tell me this disjoint cycles means what? There is no common element. Yes, in both cycle there is no common element in both cycles. So here 1 3, here also 3, and here also 3. So this is not a disjoint cycle. Here 1 3 2 4, this is a disjoint cycle. 1 2, here also 2, and here also 2 present. So this is not a disjoint cycle. Here 1 3 and 1 3 4, here 4 is present, here also 4 is present. This is also not a disjoint cycle. So correct option is option B, 1 3 2 4, because there is no common element present in both cycles. Yes. Next MCQ, which of the following are true? A permutation is called an even permutation if it can be expressed as a product of an even number of transposition. This is correct one. Next, option B is a permutation is called an odd permutation if it can be expressed as a product of a odd number of transposition. Yes, this is also correct one. So what is option C? Both A and B are true statements. Yes, so option C is the correct one. None of the O is the wrong option. Product of an even permutation is always even. Yes, product of an odd permutation is always an even, but we can express even permutation in even number of transposition. Yes, and we can express odd permutation in the product of odd number of transposition. Remember these two statements, very important statements. Yes. Next MCQ, pick the wrong one. The product of two even permutations is even. So the product of two even permutation is even. Yes, this is correct one. The product of two odd permutation is odd. The true statement is the product of two odd permutation is also an even permutation, not an odd permutation. So wrong one is this. Again, the product of two odd permutation is even. This is true statement. The product of an even and odd permutation is odd. This is also an true statement. Yes, the product of even and odd permutation is odd. True statement. The product of two odd permutation is even. This is also true statement. The product of two even permutation is even. This is also true statement. The product of two odd permutation is even, not odd. So wrong is option B is the wrong option. Next MCQ, pick the wrong statement. Every transposition is an odd permutation. Yes, it is true statement. Every transposition is an odd permutation. And identity permutation is always an even permutation. This is also a true statement. Identity permutation is always even permutation. Option C is an inverse of an even permutation is odd. Yes, so it is a wrong statement. Inverse of an even permutation is always even. Inverse of an odd permutation is always an odd. Yes, inverse of an odd permutation is odd. This is true. And even the inverse of an even permutation is even. Yes, not odd. So option C is the correct here. Yes, this is the wrong statement. They are asking pick the wrong statement. Next MCQ, which of the following are even permutations? How can we find even permutation or odd permutation? So write in the product of transposition. You can write 1 2 3 1 2 as 1 2 1 3 and 1 2. Product of 3 transposition. So this is an odd permutation. Yes, odd permutation. Option A is an odd permutation. Option B is, you can write 1 2 1 3. Yes, 1 4 1 5 1 2 1 3 and 4 5. Calculate this transposition 1 2 3 4 5 6 7. Yes, so option B is also an odd permutation. Yes. Next, last one is only one is also odd. So option D is also odd permutation. So option C is the correct one. 1 2 3 4. 4 is an even number and they are asking which of the following are even permutations. So option C is the correct one. Yes. Next MCQ. The order of permutation. So how can we calculate order of a permutation? Right, in a product of cycle, 1 maps to 3. Yes, 1 maps to 3, 3 maps to 4, 4 maps to 5, and 5 maps to 1. Yes, so complete the cycle. And here 2 maps to 2. So what is length of this cycle? 4. Yes, and here what is length of this cycle? 1. So take LCM of 4 and 1. So LCM of 4 and 1 is 4. So answer is 4. So order of permutation is 4. Yes. Then last MCQ. The order of Sn is, we know order of symmetric group of n symbols is always n factorial. Yes. Thank you.